Welcome to VLearn. Today we will discuss about the multiprocessor system, how a multiprocessor system connect with the other LANs and connect with the other devices, how they will communicate, how multiprocessor system provide a support to other devices, how to interact with them, how to control them, how to allow them and how to allow them to interact with the other devices, and they are able to communicate, they are able to share the data between the other system, and how a multiprocessor system perform multiple tasks simultaneously by using n number of processor and by using n number of resources. If a multiprocessor working and interacting and doing some task and processing some task, how much resources and which resources it shared and it uses in a sharing mode. We will discuss about all the topics and all these terms inside this session. So we will cover in this session multiprocessing and processor coupling. There is a two type of confusing terms in coupling and cohesion. Coupling, when dependency from one node to another node and one resource to another resource, and cohesion is interdependency of module, interdependency of processes. We always try to reduce the coupling and increase the cohesion between the number of processes. When we are trying to implementing or doing some task and performing some task, we always try to reduce the coupling and increase the cohesion between the number of processes, number of tasks which are currently executing and which are currently in a running state. So multiprocessor interconnection can be defined by bus-oriented system, crossbar-connected system, hypercube system, multi-stage switch-based system in which connection and in which connectivity established between more than one devices or between more than one processes based on switching technique. The next is types of multiprocessor operating system, in which multiprocessing can be easy or can be implemented for using the other techniques and other parallel techniques by applying multiple processor for achieving the goals, for achieving the multiple tasks in the same time. We can say the symmetric processing. So in this manner we have the separate supervisors for multiprocessor operating system, and as well master slave system we have, and the symmetric processing also we have. Now we will discuss about the multiprocessor and multiprocessing in detail by focusing on these topics. So we also discuss about multiprocessor operating system and its functions and the requirements for covering these topics. Multiprocessor is synchronization. We need to test and set the constraints, set the devices, compare and swap wherever it is required, fetch and add on the new things inside the multiprocessor system. So now, what is multiprocessor system? A multiprocessor system is a collection of a number of standard processors put together in an innovative way to improve the performance, speed of computer hardware. By that way, we want to improve the performance, we want to do the multiple tasks by applying the multiple processor inside the hardware devices or by attaching hardware devices. We want to do multiple tasks in the same time or at the same time by sharing some resources. So the main feature of this architecture is to provide high speed at low cost in comparison to uniprocessor systems. Uniprocessor system are those systems in which a single processor is installed and simultaneously multiple tasks you can do, but the speed and efficiency get reduced in that kind of system. But in multiprocessor system we have the n number of processor and n number of hardware devices. By attaching or connecting that devices we can achieve the higher efficiency of system and we can improve the hardware performance into the system. So the multiprocessor system is generally characterized by increased system throughput and application, speed up parallel processing. Throughput means we want to achieve the maximum results. We want to generate the maximum results by using minimum resources. That is the throughput. And by application, speed up parallel processing, if we have the n number of processors, it implicitly define we want to do multiple tasks, or we want to do parallel processing, parallel task at the same time on a single system. By applying the multiple processor, it has the greater capability and it has the ability to do the multiple tasks simultaneously. It can perform multiple tasks, multiple processing on different number of processor at the same time. So now we continue with the throughput and its efficiency, how we schedule all the processors for working and for performing their task. Throughput, as we discussed in the previous slide, is the generating the maximum number of results, maximum number of output by utilizing the minimum number of resources. The scheduling can be done in two ways. First is automatic, means by parallelizing the compiler, by parallelizing and by parallelly using of the number of processor in explicit tasking approach, where each program submitted for execution is treated by the operating system as an independent process and produce and process that independent process in isolate and complete their task on time, and by efficiently implement the resources, by efficiently utilizing the resources and generate the required results. So the next is multiprocessing and processor coupling. In this system, we want to achieve the maximum utilization of CPU, maximum utilization of our devices by doing the multiprocessing, by using the multiple CPU on a single computer system. The term multiprocessing is sometimes used to refer to the execution of multiple concurrent software processes. Concurrent means multiple processes running simultaneously in a system as opposed to a single process at any one instant. So processor coupling, it's of two types, loosely coupled and tightly coupled. Loosely coupled are those processors which can do their task independently as well as by taking some dependence and by taking some support from the other processes also. And tightly coupled are those devices which can do their task by utilizing and by using and by compromising their security with each other. And in this kind of coupling, two processes are dependent on each other for completion of their task. So the tightly coupled are those systems in which more than one system are dependent on each other for completion their task. But in loosely coupled system, a single system is capable for complete their task, but not as much efficiently as by using the support of another process or another system. So multiprocessing system is having two types coupling. Loosely coupled multiprocessor, each processor has its own memory and input-output channel. In loosely coupled, I already discussed in the previous slide, as loosely coupled system can do their task independently as well as by taking some support from other devices as well. But in tightly coupled multiprocessing, more than one or more than two systems are interdependent for doing their task. In loosely coupled, their functionality specialized processors as such input-output processors and controlled by a master processor for completion their task. But in tightly coupled multiprocessing, processors share main memory controlled by operating system and totally managed by the operating system and their devices. In tightly coupled, one process can be dependent on the other process as well, and for sharing their resources and for sharing their task. In multiprocessor interconnection, the different architecture of multiprocessor interconnection include bus-oriented system, crossbar-connected system, hypercube, in which The system connectivity and system dependence can be represented in a cubic form. Multi-stage switch-based system in which different kind of switch bar networks also used for connecting more than one system for sharing the data and resources as per the requirement. So, the multiprocessor interconnection bus system looks like a local LAN connection in which number of devices are connected on a single table and number of processors are also connected on the same cable, and a single shared memory is used by the n number of processors for completion and for doing their task efficiently. In this, they always try to utilization of the maximum memory space and maximum memory processing for sharing data, for executing data or doing their task. In the same manner, multiprocessor interconnection have the rise to a problem of contention at 2 points. One is shared bus itself and the other is shared memory. In this case, they will share the single bus as well as the memory for sharing the data, for transferring or exchanging the data and information. In this, employing private cache memory in either of two ways explained below, the problem of contention could be reduced with shared memory as well with cache associated with each individual processors. And in the next, multiprocessor interconnection is shared with the cache memory as well, because they are sharing the shared memory, and before shared memory and before any physical memory, there is the cache memory is also there, which is shared by the multiple processors inside a single system for completion or for doing their task. And in the individual processor with cache, there is number of processors, but they are having the independent cache memory, and they all are combinedly working and sharing the shared memory, and they are able to share or store the data in a memory directly, because they are having the independent cache memory, which help us for doing the task efficiently and executing task and speed up the processor speed for completion their task and for sharing the data and information by using the shared memory and connecting with the LAN on the network. Multiprocessor interconnection in cache coherence refers to the integrity of data stored in local cache of shared resources which are on a local network and which are on available network are connected, can easily shareable and can easily accessible by using cache coherence. And cache coherence of a shared resources is a special case of memory coherence in which they can access and they can speed up the executing and processing of the task of the process for completion the task or for completion the number of jobs put it into the system. By using the memory, they can store and access the data which is stored in the memory, and they are having the independent cache memory which is speed up their processing and executing speed. In multiprocessor interconnection, some time techniques which can be employed to decrease the impact of bus and memory saturation in bus oriented system, where wider bus technique is used for connecting the number of processors for sharing and for executing their tasking on a single shared memory, and split request reply protocols at memory level, where request and reply are split into two individual works and treated as separate bus transaction for doing their task for sharing and storing the data in memory. And the next is crossbar-connected switches system, in which crossbar switches are connected and connecting on the basis of requirement. If we have a switch A, B, C, D, and as well we have on the other side E, F, G, H another switches. If A want to connect with the H switches, then there is a crossbar switch which is always connected on the basis of requirement for sharing and exchanging the data and information on the network. After completion of their sharing or connection, they will release the connection, and that will again becomes the ideal for connecting the another network. The every cross point of a grid structure is attached with the switch, and that switch will be connected with the other switches as well for representing the nesting structure of network for connection and for implementing the connection between two or more than two devices for sharing the data and information. Cross needs and scale switches for fully connected network for representing the connection between the number of processes, number of devices. Processor may or may not have memory. Processor have their private memories. In the later case, the system support uniform memory access and providing the memory in a sharing mode for storage, for accessing the content from that memory and for executing their task. In multiprocessor interconnection, we have that kind of structure in which it is represented as a memory structure. This represents the number of processors are there which are closely connected with the number of memory, like P0 have to access the memory, M0, M2, N-1, it can connect with any memory on the basis of requirement as well. P1 also connect, and the n number of processors can be there. They can sharing the data or sharing the memory in a sharing mode for processing or completing their task in the same manner. So now we have the multiprocessor interconnection. Some problems. The problem of contention remains when more than two processors like P1 and P2 attempt to access the one memory module at the same time. When these two processors are trying to access the same memory module at the same time, then the problem also arises. More than two processors attempt to access the same memory module, then we have to face the problem and the speed is decreased because the multiple processes accessing the same memory and the speed get reduced. In that case, in multiprocessor interconnection, hypercubic system is also implemented. In this architecture has some advantages over other architecture of multiprocessing system. In this system, topology can be support large number of processors by providing increasing interconnection with increasing complexity. In the same manner, we have the n degree hypercube architecture. We have 2 to the power n number of nodes in this kind of architecture, in which we have to connect the number of nodes in a topological manner in the form of topology for connecting and for sharing the data, for sharing the other resources. In the same manner, multiprocessor interconnection have the number of nodes are arranged in n dimensional in a cubic form, in which each node is connected to the n number of other nodes and connected with the adjacent n number of nodes for sharing and for storing the data in the other devices and for sharing the data and information or exchanging the data for implementation and for processing of the number of processes. And the adjacent nodes n-1 are differing in 1 bit, and then nth node is having maximum n internode distance, in which we have to allow the number of system and number of nodes to execute the task and allow the number of node for the connection system or interconnection for sharing the data and information as well. And the same manner, this is the cubic representation of the number of nodes, in which number of nodes are connected with their adjacent node and they need to perform their task and processing for completion the task and for achieving the common goal. These number of nodes can connect and can share the data with the other nodes as well. And this also helps in the representation of number of nodes, and it helps in representation of which number of processes are connected and able to connect with the another process, in which we can take an example of any number of node. We are taking example for this node which is connected with the number of node like this one and this one. It has the connection with the 3 nodes and can share the data and information with these 3 number of nodes. This is the hypercubic representation of processing system. In multi-stage switch-based system, switch-based system permit simultaneous connection between several input-output pairs. It consists of several stages of switches which provide multi-stage interconnection network and which are able to represent the nesting of switching, in which number of switches are connected with each other, and at the last level they are connected directly with the number of devices and number of nodes which need to connect with the other nodes. There is you can say the number of layers and levels are there, in which number of switches are connected for extending the network, and number of nodes are connected at the last level or at the last end. In multi-stage switch-based system permits simultaneous connection between several number of input-output pairs which needs to connect and which needs to share the data and information at different number of levels. So it consists of several stage of switches which provide multi-stage interconnection network. An input-output connection contains k log square or log to the power 2 with n stages of n by 2 switches at each stage. In every stage there is the number of switches are there for connection, and for connection between the number of devices and representation of a number of devices communication with the interconnection, and by using the number of switches it represents the complexity with log square n switches are required for implementation of interconnection or for implementation of multi-stage interconnection network in the system. In multi-stage switch-based system, all inputs are connected to all outputs in such a way that no two processors attempt to access the same memory at the same time. This helps in reducing the kind of problem which occurring in the previous switching method, in which we are facing the problem when number of devices are accessing the same memory location and requesting the same memory location for processing or for completion their task. The system getting slow in that kind of problem, and in that kind of situation, for resolving that problem we have the multi-stage switch-based system. All inputs are connected to all outputs in such a way that no two processors attempt to access the same memory at the same time. So we facing the same problem in the previous switching technique, and that kind of problem is resolved in multi-stage switch-based system. But the problem of contention at a switch arises when some memory modules are contested by some fixed number of processors. We can restrict that processors for accessing the same memory or same data at the same time. We can remove that kind of collision at that kind of problem which are colliding with each other number of processors in the same. The next is type of multiprocessor operating system. In the multiprocessor operating system are complex in comparison to multi-programs on an uniprocessor operating system, because multiprocessor execute tasks concurrently. But in uniprocessor system we can execute a single task at a time, because there is a single processor and we can apply that process with a single job and for executing the number of tasks by using the limited number of resources. So there is the many constraints are there for executing the task, because we have the number of limited resources, limited number of processors which degrade in the efficiency. But in the multiprocessing system we have the number of processors for execution, and for that execute the number of tasks simultaneously or concurrently. There are three basic types of multiprocessing operating systems are there, which help for executing the process parallelly or concurrently, in which separate supervisor are there for controlling the processing of number of different operating system and for completion their task, and apply them on the number of processor which are communicating by using some switches or multi-stage switching network. That kind of controlling is also used in that kind of switching network. And the another one is the master slave switching network, in which a single system controls the whole network as a master, and the other nodes which are communicating and which are connected for sharing the data and information works as a slave. They are followed the number of instruction and follow the number of commands which are generated by the master, and they need to follow the same commands for completion their task for implementing the communication between the two or more than two network or more than two nodes by using the multi-stage switches for implementing the multiprocessor system. In symmetric supervision there is a number of processor are executing their task, and the symmetric supervision will provide the support for controlling their task and controlling their execution stage for implementing the task. In the same manner, types of multiprocessor operating system, if we discuss in detail, the separate supervisor. In separate supervisor system, each process behave independently, in which every system have its own operating system which manages local input output devices. In that kind, file system and memory well as keeps its own copy of kernel which are generating the number of requests from the user, and they will store that kind of command and request it and process them, and then generate the result by applying that command to kernel. Kernel respond that number of commands, which works as an heart of operating system, because it getting the request from the users and process them and generate that requested to the operating system, and operating system perform accordingly and generating the responses. Kernel accept that kind of responses and pass on that responses to the number of users which requesting for number of resources. That supervisor and data structure, whereas some common data structure also exists for communication between number of processors, because if a single kernel and single operating system working there, then the number of requests which are generating from the number of users and number of clients, they are not able to handle. Then we require a kind of kernel which accept the request from the user and which works as an interface between the user and the operating system for processing their command, for generating their results, and for implementing the number of tasks at the user level as well as at the kernel or operating system level. So the next is, such architecture will face the following problem, in which that kind of supervisor and kernel is there. Little coupling among processors between the number of processors which are executing or in execution state have the little coupling, and they are doing their task parallel execution for a single task, and they are dividing the problem into a number of sub problems, and that number of sub problems are solved independently. After the solution, we can integrate that all of problems and generate the single result for a single original problem. During process of failure, it regards if any process or any sub problem get failed, it regards the process efficiency or the original result. We cannot achieve the single result, or we are not able to integrate all the results and problem into a single problem if any one system get failed, because it decreases its efficiency and we are not able to get the exact or accurate result in that case. In efficient configuration, as the problem of replication arises between supervisor, kernel and data structure code and each processor, when that kind of problem is occur for representation of data and information, at the same manner we need to perform the number of tasks or number of implementation for execution the parallel task and execution of the concurrent implementation of number of processing by using number of processor for their achievement of goal or achievement of a single goal by using the number of processor concurrently. The next type of multiprocessor operating system is the arrangement of computer in a master-slave manner. In master-slave, out of many processors, one processor behave as a master, whereas other processor behave as like the slave. A single master can control the number of processors in such a manner. They behave accordingly, they perform result accordingly, they interact with other system accordingly. If a single master control all of the system, they can work according to the command, according to the instructions of master, and they need to generate the results accordingly. In master slave, out of many processors, one processor behave as a master, whereas other behave as a slave. The master processor is dedicated to executing the operating system. It works as a scheduler and controller over slave processor, because every slave need to perform their task according to the given schedule and according to the given sequences, and they need to perform the result and generate the result according to the master instruction, and after the completion of their task they need to integrate by the master and generate the final result. In the same manner, slave processors are often identified and work as a schedulable pool of resources, the slave processor execute application programs in the same manner. So the next is type of multiprocessor operating system. This arrangement allows the parallel execution of a single task by allocating several subtasks to multiple processors concurrently. In this kind of arrangement, parallel execution having the single task by every processors and every processor working on their independent task, and after completion of their task the result can be integrated for generating a single result. In this case we have the limited number of resources and we have to work with these limited number of resources by sharing the single memory, by sharing the single cache memory for speed up and for execution the task. In this limited scalability, it is the main limitation of this system, because the system and the master processor become a bottleneck and will consequently fail to fully utilize slave processor. They are not able to utilize the proper performance and proper slave ability for performing the task, because every slave is not able to do the every task, and we cannot allocate the same task to the every processor, and the same number of different subtasks are not taking the similar time, and they are not having the same kind of complexity, which takes the number of execution and which takes the number of complexity for completion their task. At the same time, we have the symmetric processing for completion the task in a multiprocessor operating system. In symmetric organization, all processor configuration are identical. In this manner, all processors are autonomous and are treated equally to make all the processor functionally identical. All the resources are pooled and are available to them for allocation and for execution of number of tasks simultaneously or concurrently. In the same way, the simplest way to achieve this is to treat the entire operating system as a critical section. In this critical section, number of processors are allowed for execution for number of tasks, and at the same time allow only one processor to execute the operating system at a one time for a single task. In the same manner, they have to achieve the execution and they need to achieve the goal, which is the given problem, and they need to solve that kind of problem with the different kind of methodology or in a different kind of architecture as the master slave and the single supervisor, and which we discuss in the symmetric processing. This all different types of methodology which we used and which we implement for implementing and processing the multiple or concurrent tasks at the same time. The next is types of operating system or types of multiprocessor operating system. In this, parallel execution of different applications is achieved by maintaining a queue of ready processor in shared memory, in which number of processors are ready for execution, in which we have to allocate, then reduce to assigning the first ready process to first available processor until either all processors are busy or the queue is empty. In the queue, we have the number of processors which are waiting for the allocation of the task, and if every processor getting the task, the queue get empty. Otherwise, there is the number of processor waiting for the allocation of the task for doing on the symmetric or multiprocessing or master slave or any kind of infrastructure or architecture in which they are able to perform their task. Now, the multiprocessor operating system have some functions and their requirements according to performance and according to the execution of the states. A multiprocessor operating system manages all the available resources and schedule functionality to form an abstraction. It will facilitate program execution and interaction with the user for processing and for doing the task concurrently, and for interaction of the user with the devices for doing the task, for allocating the resources by the processor for completion the task, which are generated the number of operating system generate the number of different tasks, generate the number of different allocation of resources. Everything is maintained inside the multiprocessor requesting in the operating system, and operating system works as a controller or works as a driver in the system which control every devices, which control and grant that number of resources to the number of processor for completion their task. In this the same way, processor scheduling undertake the following task, in which allocation of processors among applications in such a manner that will be consistent with system design objectives. It affects the system throughput. Throughput can be improved by co-scheduling several application works together for achieving a common goal, thus availing fewer number of processors to each for completion their task or for completion their allocated process or job. In multiprocessor operating system, functions and requirements are also there. Ensure efficient use of processors allocation to an application. In this, the primarily affects the speed up of the system, in which we want to increase the execution speed, or in which we want to speed up the achievement of goals in a particular sequence, in a particular ordering. The two primary facets of operating system support for multiprocessing are: the first one is flexible and efficient interprocess and interprocessor synchronization mechanism, in which efficient creation and management of a large number of threads of activities such as process or threads are available, in which we are doing the number of concurrent tasks for achieving a common goal. After completion of their task, we can integrate all of the results for generating a single result and for satisfying a single condition. In the same manner, we have the multiprocessor operating function and requirement, in which we have the memory management is the second basic type of resource that needs to be managed, because the number of processors are using the memory in a sharing mode for storing and accessing the data and content for execution of concurrent processes. In memory management is highly dependent on the architecture, and interconnection scheme is required for representation and for connection of the number of processes. The third basic resource is device management. It has received little attention in multiprocessor system to date, because earlier the main focus point is speed up of compute intensive application, in which generally do not generate much input output after the initial loading of the content into the device, into the system for execution, for processing. In the same way, multiprocessor system facilitates parallel program execution and read-write sharing of data, thus may cause the processor to concurrently access location in the shared memory, where we are executing the number of process by using the shared memory for accessing and storing the data and content into the shared memory by using some caching, and somewhere we are having the independent cache memory, and somewhere we are having the shared cache memory as well as the memory where we are storing and accessing the data and content. This is called synchronization mechanism, in which we apply the synchronization, in which a single process only is allowed to access or allowed to enter into the memory for accessing the data and content. The mechanism should make access to a shared data structure appear atomic with respect to each other for accessing and for storing the data and content inside the system. Multiprocessor synchronization test and set. The test and set instruction automatically reads and modify the content of a memory location in one memory cycle. It is as follows: function test and set, in which it tests the number of content and number of instructions from the memory and modify the content of a memory location in one memory cycle, where it put up the some set of rules and it put up the some set of boolean operation for putting the content or for applying their flags on the system, on the data, and putting that content on the system. We can apply the flags that is true or false, which generate that requested and which can alert the number of process for accessing the content. If we apply the true boolean operation and apply the flag true boolean, then the the content is able to access in that particular location. If the flag is false, then we are not able to access the content from that particular memory location in the system. In multiprocessor synchronization, compare and swap. The compare and swap instruction is used in the optimistic synchronization of concurrent update, in which the every update can be accessible and able to swap and able to exchange and able to replace with the new information in the system. This instruction is defined as follows: by using the function test and set, we can replace the information. By that way, the new data and the new operation is able to access the updated data and information, which is very much required. If we are working on the oldest information, then we will get the wrong result and we can get the older result which is not required and which is not fully satisfy the current scenario in the system. Then always we require the updated information, and that thing is very much important in this, in which it update the information for the another processes which working on the same network. In this, the multiprocessor synchronization, the other is fetch and add. Fetch means retrieve and add means some add up new information. The fetch and add instruction is a multiple operation memory access instruction in which that automatically adds a constant to a memory location and return the previous content of the memory location, in which we are accessing the data which are updated from the memory and which can be replaced from the memory, and we need to access that the updated data. In this, the instruction is defined as follows. First, function fetch and add, where the integer is taken as m and integer is taken as c. There is a two kind of parameters are there in which it applies some operation for updating the content or information in the existing content and return the results into the system. In the same manner, it will access the content which is updated in the system, and we can access the multiprocessing system efficiently for completion or for execution the number of tasks. Now we are going to start the next unit is that is block 3 and unit 2. In this, the topic is distributed operating system. In the distributed operating system, we will cover these number of topics as the distributed system, the definition part and the introduction part in which the number of systems are located in the different number of location which is controlled inside this type of system. Key features and advantages of a distributed system, then advantages of distributed system over centralized system, in which a system is controlled with the central machine with a number of client and server architecture. In advantages of distributed system over isolated PCs which are independently working for particular task, and disadvantages of the distributed system. At the same manner, we will discuss about the design goals of distributed system like concurrency, scalability, openness, fault tolerance, how much it has the ability to bear the fault and how much efficiency can be maintained if any kind of fault can be occur, privacy and authentication and transparency. The same way we have some design issues involved in distributed system as like the naming, communication, software structure, workload allocation, consistency, maintenance and Lamport scheme of ordering of number of events. Now these are the number of application model which we discuss inside this session and inside this unit, that is the client server, distributed object, distributed shared memory, in which the memory is shared in the distributed network or in different number of system in a distributed way, and the mutual exclusion when the number of devices and number of operations which request for the same number of resources at the same time kind of collision will occur, and token based mutual exclusion, Lamport-Becker's algorithm, Ricard-Agrewal mutual exclusion algorithm, Now we will use some RPC remote processor calls for works on the remote machine and for remote system, and it has some limitations also and some consideration. We will discuss about all of them. And now we start with the distributed system. Multiprocessor system have more than one processing unit sharing memory peripheral devices. They have greater computing power and higher reliability. In multiprocessor system, we can do multiple tasks and we can do multiple jobs execution at the same time by using the different number of peripheral devices at the independent way. Now multiprocessor system are classified into two types. First is tightly coupled. Each processor is assigned a specific duty, but processor work in close association, possibly sharing one memory module. In tightly coupled, every processor doing the single task, but they are dependents and they work together for achieving a single goal and sharing the single memory. That kind of processing is done inside the tightly coupled way, and that is done inside the tightly coupled processing system. In loosely coupled, that is the distributed, each processor has its own memory and copy of the operating system. By using that memory and operating system, it can do the simultaneous multiple tasks in the same network and can control on the number of jobs which are executing in the system on the same way. A distributed computer system is a loosely coupled collection of autonomous computers connected by a network using system software to produce a single integrated computing environment in which it needs to complete the number of jobs which are independently working on a single system. At the same way, a distributed operating system differs from a network of machines, each supporting a network operating system in only one way for execution of tasks. So, with distributed operating system, the entire system is itself distributed across the network in which we can execute the task, in which we are going to share some data or information on distributed environment in which they have some number of independent or separate number of resources and devices for implementation of communication or for implementation or execution of the task and process. So the distributed environment is efficient, and in this environment we can work on multiple tasks at the same time for achieving a single goal or different number of tasks at the same manner. A key feature of distributed system they are loosely coupled because they are working independently in different number of locations, but they are connected through some network. Remote access is many times slower than a local access. If we need to access some system from A location to B location, then there is a speed is the constant in somehow, but we are working on a same system and we have to execute or complete our task on the same system, then the speed will get increased and there is no any kind of dependency. If there is some dependency, then constant will increase. If there is no dependency, then some kind of external constant get automatically removed from the process and from the system. Nodes are autonomous, in which workstation resources are managed locally and they work and able to do that multiple tasks at the same time and can do the task in similar manner for execution of system. Network connection using system software for execution and for implementation number of tasks for achieving the common goal for implementation of different number of execution. We need network connection, and that way we require a system software for execution in the same manner. Remote access require explicit message passing between the number of nodes for sharing the data and information. And the same way we have message or CPU to CPU for implementation of communication and for implementation of message passing between the system to the system or CPU to CPU for acknowledge to each other about the number of devices and resources which are available on the network for execution. Protocol for reliability We have the flow control, failure detection, etc. implemented in software, which help us about understanding the network and help us for sharing the data and information throughout the network. The only way two nodes can communicate is by sending and receiving network messages. This differs from a hardware approach in which a hardware signaling can be used for flow control or failure detection, in which advantage of distributed system over centralized system are it provides and it gives the better price performance than mainframe system, in which they can do the single task or they can work independently. More computing power, some of the computing power of the processor in the distributed system may be greater than any single processor available or parallel processing system which are working on the network. Some applications are inherently distributed in this system. Improved reliability, because system can survive crash of one processor. If one processor get crash, the other system will take up its workload and can do their task simultaneously at the same way which is done by that particular system which is get crashed. Incremental growth can be achieved by adding one processor at a time. If we add up some new processors, the incremental and the speed up you can measure at the same time for when the running process get completed. Incremental growth can be achieved by adding one processor at a time. Shared ownership facilitated in this manner or in this scenario. We have shared utilization of resources. If a number of processors working in the same environment or in that environment where they are able to exchange or share the data and information, they can communicate with each other by using communication, and they can communicate with each other by sending and receiving some requests and responses. And they have the better performance and flexibility than isolated personal computer, because in personal computer if they get crashed, the whole task will be get in pending state, but in this stage in sharing processing, the if a single process get crashed, that task will be shared by the other processor and they will complete the pending task which is crashed and the task of the crashed system. Simpler maintenance if compared with the individual PC. It becomes very easy for maintenance if we compare with the individual PC, because individual PC is complex in doing the task and it is difficult to finding the fault, but in that distributed environment, if the number of processor doing the different number of tasks, we can identify that particular system by finding which task in a pending state. We can identify that system and can apply the changes on that particular system at the same manner. These are the disadvantages of distributed system, like network performance parameters, in which we have a latency time in which the system get delay in response. A delay that occurs after a send operation is executed before data start to arrive at the destination computer, and the second is data transfer rate, in which the speed at which data can be transferred between two computers once transmission has begun. The next one is total network bandwidth. There is some dependence of transferring the data on the network bandwidth, total volume of traffic that can be transferred across the network in a given time and in the available time slot. There is some dependency or reliability is also exist in the underlying network, and higher security risk is there, because due to more possible access points for intruders and possible communication with the insecure system is also exist. Next is design goal of distributed system. These are the number of design goals for distributed system. First, concurrency, in which number of processor and number of system doing and working on different number of tasks for achieving a single goals, or you can say the main task is divided into number of subtasks and that are executing and parallelly or concurrently working on their subtasks on their problems. Scalability, in this we can scale up and we can divide and we can put up and we can finding, and we are able to checkup, and we are able to find their skill up, the work in progress, and we can find we can put up the progress state, and we can able to check its how much data is completed and how much processing is completed and how much is remaining. We can define in accurate percentile in scalability process. Openness, the number of systems are able to connect or communicate with the number of other devices in this kind of network. Fault tolerance system is capable for performing their task. If any kind of fault is occurring in the particular system, we can say that is the fault tolerance, and that is the height of the system for ability to bear that fault and performing the task at the same time. Transparency is the, you can say, the feasibility of their working environment. And next one is privacy and authentication, in which we are going to maintain the privacy of the system, about the task, about the user, and about the login process which is done inside that particular system. And authentication is the process in which an authorized person is only allowed to do that kind of task on that particular system. Now we discuss about them in detail. In design issue to be considered for distributed system are like naming which system doing which one task, and which kind of communication establishing between the number of processor and software structure, which kind of software structure and which software structure is used by a particular system for implementing that particular task, and workload allocation, in which we define the workload done by the particular process and how much workload on that particular process, in which it is giving that kind of performance which is scale up easily. Consistency, maintenance as well. There in naming, a name is a string of character used to identify and locate a distributed resource on the network. An identifier is a special kind of name that is used directly by the computer to access the resource on the network. And the example of the identifier for a Unix server would include at least one an IP address and two a port number. The IP address is used to find the node that runs on the server, and the port number identifies the server process on that particular node. So these two things help us to identify the which system working on which network and which system performing which one task on that particular network, and the request we can identify which request is generated by which particular system, because we already allocated the name as an IP address, and we can identify the port number in which and from which port that kind of request and that kind of problem is occurring into the network. The IP address is used to find the node that runs the server, and port number identify the server process on that particular node. So resolution is the process of turning a name into an identifier. We turn the name into identifier for identifying the particular system or particular node on the network performed by a name server. It is also called binding, as in binding a name to a distributed service. So the communication and server structure is also there. In communication, getting different processes to talk to each other by sending some messages, by sending some requests and responses. In remote method invocation, a single machine can access or can retrieve the data or content from other machine in a different, which is located in different environment. Software structure, the main issues are to choose a software structure that support our goals, particularly the goal of openness for achieving the task or for completion the task. In the same manner, we thus want structure that promote extensibility and otherwise make it easy to program the system for completion the task. And the workload allocation, the key issue is load balancing. The allocation of the network workload such that network resources as CPU, memory, disk are used efficiently on the network for achieving the concurrent processing. For CPU, there are two key approaches are there. They are processor pools and ideal workstation. In processor pools, a number of jobs are processing inside the number of jobs are processing inside the distributed environment, we can select the number of jobs or process from the processor pools, and we can run that process into the ideal workstations. Consistency and maintenance. The final issue is consistency. There are 4 key aspects of consistency, that are atomicity, coherence, failure consistency, and clock consistency. At the same time, we have the distributed system structure. In which distributed system structure, there are 3 main alternative way to structure a distributed application. The 3 distributed system application models are: the first is client server, that also use the RPC, remote processor call, and the another is distributed object, which is working on the different number of location at the same time, and the distributed shared memory, in which a single system or more than one system sharing the number of memory in a sharing mode, or you can say there is a single memory which is used or shared by the number of processors on the same network for storing and accessing the data or content in that particular system. Application model 1. In client server, a designated node export a service. This node is called the server. Node that import and use the service are called clients. In the client server architecture, server always respond to the number of clients and respond to the number of requests which are generated by the number of clients, and in the same manner, node that import and use the service are called clients. Clients communicate with server using a request and response protocol. Request response differ from other protocol because it helps for initiating and closing the communication between 2 or more than 2 devices. In the same manner, peer-to-peer protocol don't have a designated server for implementation of communication. In the same way, streaming protocols such as TCP/IP work differently, as we will see a couple of classes from now. So application interface can be either send, receive, or RPC is the remote processor call, which help them to communicate on the different or distributed environment between the 2 or more than 2 systems for sharing the data or information, or the process status between the number of system or number of processor which are working on the same task independently or coherently. They are able to access the content in the different environment or network by using a single shared memory. And this is the kind of architecture which represent the client server environment, in which there is the number of client which request and getting the response from the server on the network for generating or for executing the task, and they are able to share the memory also in a sharing mode. So we will continue this unit in the next class from here. Thank you.